Hello students and welcome to lesson 10. It's inequalities and absolute value. Of course, we're a little familiar with both of these topics, if you will, inequalities and absolute value. You guys know that absolute value has these brackets that sort of look like that, and an open dot goes with this inequality, which is less than or greater than. Closed dot, when you're graphing, goes with less than or equal to or greater than or equal to. Now, greater than, we're going to be using this word today. So that's greater than or equal to. Less than has this math verb. Less than or equals that. These words today are going to be very important to us in the way that we set up an absolute value inequality. Now, looking at example one, you remember graphing things like this where you'd go in there and on a number line represent the values that x could be by putting an open dot. You know that the x is bigger, so you would have shaded to the right. This problem, -1 is less than or equal to y. You know that -1 is definitely going to be on the number line. You know that you're going to use a solid dot, as we discussed up above, but the y is getting eaten by the alligator mouth or the Pac-Man, whichever you want to think about that as. So we're going to shade to the right because those values are bigger. Looking at this inequality, we're trying to isolate that variable, so we're going to go ahead and subtract 5 from both sides. We'll clean that up. We got x is less than 2, and we'll put 2 on the number line, open dot. It's an open dot there, sorry, and shade to the left there. Make sure that's an open dot there, guys, on your paper. It looks sort of closed in on mine. This problem here looks like a multi-step inequality. So we'll start off by adding 4 to both sides. Clean that up. We have -2y is less than, let's see, 6. Then we have to divide both sides by -2. And we have y. The fish hook is right up here, reminding you that you have to flip that inequality sign. Don't forget that, folks. We'll see that happen for us today. And we have -3 when we do that division. So we're going to put -3 on our number line. It's an open dot going on there. The y is greater than, so we're going to shade to the right. Last review type problem we have going here, we have -w plus 4 is less than or equal to 9. So we'll subtract 4 from both sides. Draw a line, bring down this inequality sign, but we have a -w on the left side of that math verb and a 5 over here. 3 ways to get rid of that negative sign. I always prefer just multiplying by -1. So that's what I'm going to do. And I have w, don't forget to reverse or flip that inequality sign, is greater than or equal to -5. So I'm going to put -5 on there, a solid dot, and I'm going to shade to the right. Okay. Now, let's take a look down here at example 2 for a moment. And this is where we need to understand a little bit more of, I guess, where we're going with today's lesson. So this is going to start our journey and possibly our understanding. You know, from this problem right here, we did things that look like this with absolute value. We said the absolute value of x is equal to 3. And you knew that there were 2 values down here on the number line. If you were going to talk about that, you'd say that that could be -3 or a +3. And those are the 2 values that you could highlight on a number line, but this is an inequality. So you might have to think of different values. So if you were going to look around on this number line and talk about where you could find values that make this expression true, you might think about over here at a +4 or +5, or maybe over here at -4 and -5. And those values would keep on going. So if you were just going to guess about these inequalities in this area right here, it wouldn't work. So if you were going to guess on that, you would maybe put an open dot there and shade to the right and represent all those values. But likewise, over here, you have a second choice, and you might put an open dot there and shade to the left. And we're going to refer to this, pay attention to this inequality, which you're again saying absolute value of x is greater than. And we're going to refer to greater than problems as, I'm going to call those or problems. Okay? Because a couple things could happen. That x could be less than -3, or x could be greater than +3. Now remember what I wrote here in a few minutes, because we're going to use this idea to set up some more complicated problems. Now, this problem says the absolute value of x is less than 4. And again, we had stuff that looked like this before. X in equation form, the absolute value of x is equal to 4. And again, we had two opportunities there. We had a 4 and a -4 that would make those values true. Well, let's start thinking about values that we could plug in here and put in the absolute value. What we would find is maybe like if we put 0 in there, that'd be true. If we put like +2, that would be true. -2, if we put that in there, that would be true. But these values out here, beyond here, are not true. So it appears that all the values that make this expression true are contained between the -4 and the +4. And we're going to refer to that graphing or this setup that I'm going to show you as an AND problem. And we're going to talk about the values that x could be, that the x in this case is going to be bigger than -4 and less than +4. So we're looking at values that are in between there. So remember this up here, that the AND or setup, because we're going to go right up here to example 2 and utilize some of this. Now, example 2, I'm going to show you how to set these up, and this is real important that you pay attention to this. This is going to lead you to success on the quiz coming up. But if we see this sign right here, again, this is a greater than sign, and we're going to call that an OR problem. So here's how we set it up. We're going to set up and talk about 2x plus 6. We're going to flip this sign. It's going to be less than or equal to -14. Or we're going to say that 2x plus 6, just like we see it written up here without the inequalities, is going to be greater than or equal to 14. So we split this into two equations. Sound familiar to you? And we're going to talk about the negative value on this side in this case and the positive value over on this side. And once we have this set up, just like we did with equations, we're just going to go through and solve this, both of them. So we subtract 6 there. We get 2x is less than or equal to -20. Divide by 2. No fishhooks here. We have x is less than or equal to -10. Over here, following the same steps, we're going to subtract 6 from both sides. We have 2x is greater than or equal to 8. Divide by 2. And we have x is greater than or equal to 4. And on the graph, let's put these two values on here, -10 and the 4. We're going to have solid dots here on both of those. For this one, x is less than -10. With this solid dot, we're going to shade to the left. And for this one, x is greater than or equal to 4, so we're going to shade to the right. And notice what that OR graph looks like. A little bit of a different setup for the second absolute value inequality. I'm going to frame this. I'm going to take this 9. Again, we're going to represent the negative value there. We're going to put that same inequality sign there, and we're going to put it there. But we're going to put the positive 9 to the right. And all I'm going to do is take what's in absolute value brackets and put it right here between those two inequalities. So a little bit of different setup here on purpose. Let's go through and solve this. So we're going to go ahead and subtract 1. Now watch how I do this from just about everywhere on all the sides of the math verb there, if you will. So I get -10. I'll write down my inequality signs. I have a -2x there in the middle, and I have an 8 over here on this right side of that math verb. Then I have to get rid of this -2 that's multiplying with my x. I'm going to divide everything by -2. Make sure my negative signs are in there. And what happens when I multiply by negative? I got to flip or reverse my inequality sign. So I'm going to do both of those. I'm going to leave my x in the middle. I have a 5 there. and I have a -4 over here. So I'm going to put these on my number line. 5 is going to go over there. -4 is there. And the x is bigger than the -4 if we look at that comparison, or we can say that the x is less than the 5, whichever way you want to do that. So open dots on both of those, and we find out that the x is going to be in between those values. Again, it's going to be less than, because the arrow is pointing at it, the 5, but it's bigger than the -4. So you're going to find all those values in between there. Again, that's what an OR problem looks like. Now, the graph of the solution set of an absolute value inequality will either be a segment between 2 points, like you see there on a number line, or 2 rays going in opposite directions from 2 points on the number line. Now, I'm going to give you a moment here. I want you guys to go ahead and type in your Desmos here, for example, 4. So grab your Desmos if you have that. We're going to use that. And so take a moment, pause if you need to, type that in your Desmos and tell me what you see. Now, you may have to zoom out a little bit, and my guess is that you had if I was going to sketch out on your screen, and that you had maybe a line that looked like that with some shading to the right, another vertical line with some shading to the left. Now, finding those lines are maybe a little bit of a problem. My guess is that to see what you just saw, you had to zoom out a little bit. So you had to zoom out some. And some of y'all are looking for this x-axis. So you click down on this line, but it wouldn't let you do anything. So what I'm going to suggest you do is go into another calculation box, if you will, and type in a y equals 0. And what that will do is it'll put a line right on your x-axis, which will allow you to access where these points are that you're looking for, that are right there and right there, because those are those points that you're looking for. And if you do that, you'll notice, or come pretty close, that you're right there at 9.5, of course, which is a decimal, and -14.5 for that one. Now, based on this, we have a solid dot that's going to go on there, just like you have a solid line up here on your Desmos, and the shading went to the right, and on this one, the shading went to the left. Now, you can zoom in on these areas also, and that might give you some clarity of where those points are going to be located. Now, take a moment, pause the video if you would, and go ahead and graph these guys right here, or this one. Again, I would type that just like you see that, and again, I would put in y is equal to 0 just in case you want to see another line on there. Now, just looking at the math verb here, you know this is going to be a AND type problem, just based on that inequality. That's going to be an AND problem. So you're looking for maybe shading in between. Did it show up that way? Well, I think if you type that in there, you might have up on your graph, I don't know, if you're looking at your coordinate graph, you might have dash lines here, I'm guessing, graphing, and you had shading in between those dash lines. So again, you're looking for that point and that point, which if you zoom in or you use the pointer tool along that y equals 0 line, you're going to find out that those lines came down between or on -4 and 5. You're going to have an open dot, because a dash line, and you're going to shade in between. Now, you might find it helpful, as I said, to type in y equal in expression box and Desmos. That's one thing. And if you don't like the way things are written sometimes, because not everything's written the way we have it here, so if you like the format that everything's written, you can use the reversal property. Or I guess it's a version of the symmetric property to rewrite your inequality. So for example, if something was written like 2 is less than the absolute value of x plus 1, and you didn't like it, you could rewrite that. Oh, let me slide that up for you guys, sorry. You could rewrite that with the absolute value over here x plus 1. You got to flip that inequality sign so the arrow's pointing at the 2 and write it that way. And then use your and or setups. And if you're doing it by hand, just work it out like you always have. If you're using your Desmos calculator here, suggestion again is to use that y equal 2. Now, we'll come back and talk about these. If you need for me to show you on the Desmos calculator how to do some of that, I'll be happy to do that. Again, we have two types of situations here. Big deal is over here in your notes about understanding greater than being an or type setup and a less than being an and setup. And again, your two setups are in the top right here. Very important that you keep track of this example 3. Hey, thanks for watching. We'll see you in a sec.